Good day, senior high school students of Kawayan City National High School. For today's video lesson, we will talk about identifying the length of confidence interval. To start our lesson, let's define first what is a confidence interval. A confidence interval is how much uncertainty there is with any statistic. Confidence intervals are often used with a margin of error. It tells you how confident you can be that the result from a survey reflect what you would expect to find it were possible to survey the entire population. Confidence intervals are intrinsically connected to confidence level. Let's have the general formula of a confidence interval. It is point estimate plus or minus tabular value multiplied to standard error of the point estimate. And the tabular value depends on the sampling distribution of the point estimate. Let's talk about the confidence interval for an unknown population mean and known standard deviation. The confidence interval for unknown population mean and known standard deviation is defined mathematically as x bar plus or minus quantity of z alpha half multiplied to sigma divided by the square root of n, or x bar minus quantity of z sub alpha half multiplied to sigma divided by the square root of n is less than mu is less than x bar plus quantity of z alpha half multiplied to sigma divided by the square root of n, where your x bar is the sample mean, that is the point estimator. Your z sub alpha half is the critical value of the z with a confidence interval of 1 minus alpha. Your sigma is your population standard deviation, and your n is the sample size. The lower limit of the confidence interval is x bar minus quantity of z alpha half multiplied to sigma divided by square root of n. And the upper limit of the confidence interval is x bar plus z sub alpha half multiplied to sigma divided by square root of n. Let's have the steps in identifying the length of confidence interval for unknown population mean and known standard deviation. Step 1. Identifying the given variable. That is, the population standard deviation or sigma, the sample mean or the x bar, and the sample size, that is n. Step 2. Determine the confidence level and appropriate z sub alpha half using the values of z of importance. For example, we have z value, that is 1.645, 1.960, 2.326, 2.576, 3.090, 3.291. Its confidence level are following: 90%, 95%, 98%, 99%, 99.8%, and 99.9%. Step 3. Identify the length of the confidence interval. Number 1, that is, compute for the lower limit. The lower limit formula is lower limit is equal to x bar minus z sub alpha half multiplied to sigma divided by the square root of n. Number 2, compute for the upper limit. The formula for the upper limit is equal to x bar plus quantity of z sub alpha half multiplied to sigma divided by the square root of n. And then the step 4 is construct and interpret the confidence interval. Let's have an example. A survey studying the income of individuals in a certain municipality was conducted. A population standard deviation of 1,000 pesos and a mean income of 15,000 pesos was gathered from 49 individuals. The question is, identify and interpret a 90% confidence interval for the true mean income of the individuals in a certain municipality. let's have the solution. First is to construct and interpret the 90% confidence interval for the true mean income of the individuals in a certain municipality. Step 1. Identify the given variables. Let's have the population standard deviation or the sigma that is equal to 1,000. Next is the sample mean, which is your X bar that is equal to 15,000 pesos. Next is the sample size, that is your N, that is equal to 49. Step 2. Identify the Z sub alpha half with a 90% confidence level. So, hahanapin nyo dun sa table yung merong 90% na confidence level. Ano yung katumbas niyan? Z alpha half. And that is 1.645. Step 3. Identify the length of the confidence interval. First is to compute for the lower limit having a formula of lower limit is equal to X bar minus Z alpha half multiplied to sigma divided by the square root of N. At meron na tayong X bar, meron na tayong sigma, and then meron na tayong N. And also, meron na tayong Z alpha half, that is 1.645. So let's substitute the given in the formula. So we will now have 15,000 pesos minus quantity of 1.645 multiplied to 1,000 divided by square root of 49. So, simplify muna natin yung 1.645 multiplied to 1,000 divided by the square root of 49. We will now have 15,000 minus 235. So, 15,000 minus 259, we will now have our lower limit, that is 14,765. Okay. Next, let's compute for the upper limit having a formula of upper limit is equal to X bar plus Z alpha half multiplied to sigma divided by the square root of N. Again, we will substitute the given in the formula. We will now have 15,000 plus quantity of 1.645 multiplied to 1,000 divided by square root of 49. Simplifying the equation, we will now have 15,000 plus 235. So we will now have the upper limit 15,235. For the step 4, construct and interpret the confidence interval. Okay? So our answer is therefore the 90% confidence interval is for quantity of 14,765 and 15,235, or 14,765 is less than the mean, or mu is less than the 15,235. Hence, we are 90% confident that the true average income of all individuals in a certain municipality is between 14,765 pesos and 15,235 pesos. Let's have another example. The following were observed weights in kilograms of a random sample of 20 learners. Assuming that the population standard deviation of the weights of all learners in the class is 9 kilograms. So we have 40, 45, 46, 48, 48, 50, 55, 55, 56, 58, 50, 59, 60, 60, 60, 62, 62, 64, 64, 65, and 66. The questions are: identify and interpret a 99% confidence interval for the true mean weight of the learners, and identify and interpret a 95% confidence interval for the true mean weight of the learners. Let's have the first question. Construct and interpret a 99% confidence interval for the true mean weight of the learners. We have step 1. Identify the given variables. We have the population standard deviation, that is the sigma, that is 9. We have the sample size, that is n, that is equal to 20. And the sample mean, that is x bar. We don't know our x bar. We must solve for the sample mean since it is not found in the given variable using the sample mean formula of ungrouped data. So we have the formula x bar is equal to the summation of all the x or our data. So we have now x bar is equal to 40 plus 45 plus 46 plus 48 plus 48 plus 50 plus 55 plus 55 plus 56 plus 58 plus 50 plus 59 plus 60 plus 60 plus 60 plus 62 plus 62 plus 64 plus 64 plus 65 plus 66, that is equal to 1121 divided by 20, and that is equal to 56.05. So we now have our x bar or the sample mean that is equal to 56.05. We solved already what is our sample mean, and that is 56.05. Let's now have our step 2. Let's identify the z alpha half with a 99% confidence level. Sa table, hahanapin natin ang 99% confidence level. At pag nahanap na natin, hahanapin natin ang katumbas niyang z sub alpha half, and that is 2.576. Step 3. Let's identify the length of the confidence interval. First is to compute for the lower limit having a formula of x bar minus quantity of z sub alpha half multiplied to sigma divided by the square root of n. Since we have our value of x bar, our z alpha half, and sigma and n, let's substitute that in the given. We will now have 56.05 minus quantity of 2.576 multiplied to 9 divided by square root of 20. Let's simplify first the quantity part of our equation. We will now have 5.18. So our equation now becomes 56.05 minus 5.18. We will now have the lower limit in a value of 50.87. Second, compute for the upper limit having a formula of x bar plus z alpha half multiplied to sigma divided by the square root of n. Let's substitute again the given. We will now have 56.05 plus 2.576 multiplied to 9 divided by the square root of 20. Let's simplify again the equation having the parentheses. That is 5.18. So we will now have 56.05 plus 5.18. Our upper limit now becomes 61.23. Our step 4, construct and interpret the confidence interval. Okay. Therefore, our 99% confidence interval is quantity of 58.87 and 61.23, or 50.87 is less than mu or mean is less than 61.23. Hence, we are 99% confident that the true mean weight of the learners is between 50.87 kilogram and 61.23 kilogram. Now, let's talk about the confidence interval for unknown population mean and unknown standard deviation. The confidence interval for an unknown population mean and unknown standard deviation is defined mathematically as x bar plus or minus quantity of t sub alpha over quantity of 2 and n minus 1 multiplied to s divided by square root of n, or x bar minus quantity of t sub alpha over quantity of 2 and n minus 1 times s divided by square root of n is less than mu is less than x bar plus quantity of t sub alpha over 2 and n minus 1 multiplied to s all over square root of n, wherein your x bar is the sample mean, that is your point estimator, your t sub alpha over quantity of 2 and n minus 1 is the critical value of z with a confidence interval of 1 minus alpha %. Your s is the population standard deviation and your n is your sample size. The lower limit of the confidence interval is x bar minus t sub alpha all over quantity of 2 and n minus 1 multiplied to s divided by the square root of n. And the upper limit of the confidence interval is x bar plus quantity of t sub alpha over quantity of 2 and n minus 1 times n times s divided by square root of n. Now, let's have the steps in identifying the length of the confidence interval for a known population mean and unknown standard deviation. Step 1. Identify the given variables. We have sample size, that is n, sample mean, that is your x bar is equal to summation of all your x, standard deviation, that is s, that is equal to square root of summation of all x's multiplied to x sub 1 minus x bar squared all over n minus 1. Step 2. Determine the confidence level and operate t sub alpha all over quantity of 2 and n minus 1. We will use the standard t distribution table or the one-tailed t distribution. Step 3. Identify the length of the confidence interval. First, we will compute for the lower limit, having a formula of x bar minus quantity of t sub alpha all over quantity of 2 and n minus 1 multiplied to s all over square root of n. Second is compute for the upper limit, having a formula of x bar plus quantity of t sub alpha all over quantity of 2 and n minus 1 multiplied to s all over square root of n. Step 4. Construct and interpret the confidence interval. Let's have an example. 11 regions in the Philippines are randomly sampled. In each region, rainfall was monitored for 1 year, and the following total yearly rainfalls in centimeters were recorded. That is 145, 185, 209, 213, 241, 255, 255, 262, 269, 276, 297. Assume that the yearly rainfalls within the region are normally distributed. Identify a confidence interval for true mean rainfall in the Philippines with 99% confidence level. Let's have our solution. We have step 1. Identify the given variables. We have our sample size, that is n, that is equal to 11. Okay? For our sample mean, that is your x bar, having a formula of summation of all x divided by n. For the summation of all your x, we will now have 145 plus 185 plus 209 plus 213 plus 241 plus 255 plus 255 plus 262 plus 269 plus 276 and plus 297 divided by 11. Let's simplify it. We will now have 2,607 divided by 11. And dividing it, we will now have a value of our x bar that is 237. So we now have our sample mean that is our x bar that is 237. Let's now have our standard deviation. S is equal to square root of summation of all your x multiplied to x sub 1 minus x bar squared divided by n minus 1. For us to compute for the x sub 1 minus x bar squared, let's have our table. So for our x, we will now have 145, 185, 209, 213, 241, 255, 255, 262, 269, 276, and 297. I'm talking to the data that is in the table. Okay, so our x bar is 237. We will subtract our x and our x bar that is 145 minus 237 is equal to negative 92. Okay, on the second line, we have 185 minus 237 is equal to negative 52. On the third line, we have 209 minus 237 is equal to negative 28. On the fourth line, we'll now have 213 minus 237 is equal to 24. On the fifth line, we now have 241 minus 235 that is equal to 4. And continue it. Okay, so now let's have our fourth column, that is x minus x bar squared. We will just square the difference in our third column. That is for the first line, that is negative 92 squared. We will now have 8,464. For the second line, we have negative 52 squared. We will now have 2,704. For the third line, we will now have negative 28 squared. That is 784. For the fourth line, that is negative 24 squared. That is 576. Then followed by 4 squared, that is 16. Then 18 squared, that is 324, 18 squared, 324, 25 squared, that is 625, 32 squared, that is 1024, 39 squared, that is 1521, and then the last is the 60 squared, that is 3600. We will just add all our x minus x bar squared. We will now have 19,962. We will substitute that in our formula. S is equal to summation of x multiplied to x1 minus x bar squared divided by n minus 1. So we will now have S is equal to square root of 19,962 divided by 11 minus 1. We will now have square root of 19,962 divided by 10. And then simplifying it, we will now have the square root of 1,996.2. Simplifying it, we will now have our standard deviation that is 44.6789. So we identify already our variables, that is n, that is equal to 11, our x bar, that is 237, our standard deviation or s, that is 44.6789. Step 2, let's determine the confidence level and appropriate T alpha half. Alpha over 2 and n minus 1. Our confidence level at 99% is alpha is equal to 1 minus confidence level. That is 1 minus 0.99. That is equal to 0.01. Our alpha half is alpha divided by 2. That is 0.01 divided by 2. That is equal to 0.005. Let's have now our degree of freedom, that is having a formula of n minus 1. That is equal to 11 minus 1. That is equal to 10. Using the t distribution table, let's find our t sub 0.005 and 10. That is equal to 3.169. So we're done with the step 2. Let's have the step 3. Identify the length of confidence interval. First is compute for the lower limit having formula of x bar minus quantity of t sub alpha all over 2 and n minus 1 multiplied to sigma and multiplied to s all over square root of n. Let's substitute the given in the formula. We will now have 237 minus quantity of 3.169 multiplied to 44.6789 divided by square root of 11. Simplifying it, we will now have 237 minus 42.690. Simplifying it, we will now have our lower limit, that is 194.3098. Second, compute for the upper limit having a formula of x bar plus quantity of t sub alpha all over 2 and n minus 1 is equal to s divided by square root of n. Substitute the given, we will now have 237 plus 3.169 multiplied to 44.6789 divided by square root of 11. That is equal to 237 plus 42.690. Simplifying it, we will now have our upper limit, that is 279.6902. Step 4. Construct and interpret the confidence interval. That is, therefore, 99% of confidence interval is quantity of 194.3098 and 279.6902, or 194.3098 is less than the mean is less than 279.6902. Hence, we are 99% confident that the true mean rainfall in all regions in the Philippines is between 194.3098 centimeter and 279.6902 centimeter. That's all for today's video lesson. If you have a question, clarification, don't hesitate to message me in my messenger account, that is Kim Francis Season Alam. Till next video lesson, goodbye!